Last time we started talking about some combinatoric techniques, namely we talked about factorials, permutations, and combinations, which are tools that we can use if we're trying to count something. Both permutations and combinations are asking how many ways we can select a certain number of elements from a larger set. The distinction, though, is that with combinations, we don't care what the end ordering is, whereas with permutations we do. So if our set is 8 people running a race, a permutation, when we are selecting 3 people, cares which one is first, second, or third, whereas a combination doesn't care which one is first, second, or third. Today we're talking more about combination and sort of the types of questions that this component can be used for. Often questions aren't as cut and dry as, here's a set, how many ways can we select a certain number from it? Often there's, maybe a little bit more going on. So here's the bagel problem. You go to a store and they have a sale where you can get 12 of any sort of bagel you want. The types of bagels they have are plain, blueberry, sesame, and everything. And you can have really any combinations of these choices that you want. So my question is, how many choices do you have? How many different combinations of these 4 elements can we fit into a box of 12 bagels? So my tip last time was to start off by writing down a few of the things that you're trying to count. So for example, maybe we really like plain bagels, so we want all 12 to be plain. Or we want it to be balanced, so we want 3 of each. Or just some other seemingly random solution. So there are a lot of numbers on this list. The one thing that we don't want to have duplicated is an entry like this middle one, but just ordered a different way. 3 plain, then 3 blueberry, then 3 sesame, then 3 everything is really the same when you take the box home as those 12 just in a different order, right? So the order of the selection of these doesn't matter. However, I've written them so that they're sort of clustered because I think that's easier to think about that way. So one route that we could go that ends up being more trouble than it's worth involves saying, all right, this first bagel can be one of any of these 4, and then the second bagel, well, could be any of those 4, etc. So we're tempted to say, hey, there are 4 times 4 times 4, or 4 to the 12th, possible choices for 12 bagels, each of which that come from here. But the problem is, again, when we take them home, the order in which that they're in the box doesn't really matter to us. So we are double counting in a bunch of different ways. And keeping track of how many different types of double countings we have can actually be really tricky. So rather than phrasing a question like this, we're going to recast it in another way. And this is going to let us use a combination formula to come at the question from a different angle. So the point of this example is to illustrate that reformatting a question, or reformatting how we think about a question, can maybe give us another option. So rather than listing out the elements like we did maybe for this second example, I'm going to separate them out and divide them with some vertical line, so some bar. And we'll replace our specific letters with more generic symbols, like a star. So this is called the stars and bars technique. And the idea is that the first cluster, or arbitrarily one of these clusters, corresponds to the plain, whereas another cluster corresponds to the blueberry group, etc. So this way of writing down this pattern of stars and bars is corresponding to the same solution that we talked about in our second example here. The idea is that a bar is separating out each of the groups. We can also write our first example using this format, where everything in front of the first bar corresponds to being a plain bagel, whereas everything between the first and second bar is a blueberry bagel, everything between second and third is sesame, and everything after the third is an everything bagel. So the first example has none of those, so there are no stars in those 3 regions. So take a moment to decide for yourself if you think that this first way of keeping track of possible solutions is really the same thing as the second way, just with different notation. if you do agree that these two notations are equivalent, this question becomes how many ways are there to write one of these star and bar diagrams? So doing what I usually like to do with these is I like to think of a certain number of blanks, a certain number of slots, and then filling each of those slots with either a star or a bar. So if I have all of these openings and I choose somewhat arbitrarily, so if I have all of these openings and I choose 3 places to put a bar, so let's put one here, and one here, then that choice of 3 positions is the same thing as a choice of how many of each type of bagel we want. Once I've decided to put those down, then I've decided that I want 1 plain bagel, I want 5 blueberry, 3 sesame, and 3 everything. So the question of how many different options do I have is the same as the question of how many different positions or how many different ways can I write 3 bars. Maybe I want these 3, or maybe I want these 3. Well, since there are a total of 15 slots, there are 15 choices for my first bar. Then once I've placed that one, there are 14 choices remaining, and then there are 13 choices after that. 15 times 14 times 13 overcounts a little bit because it doesn't really matter which bar is which. So we want to divide by the number of ways that we can permute or rearrange the bars, because this one secretly being the one that was chosen first, and this one second, and this one third, gives us the same answer as choosing this one first, then this one, then this one. So any possible way of ordering these 3 gives us the same answer, so we want to divide by how many orderings there are. We've seen questions like this before: divide by 3 times 2 times 1. Or, put another way, the count that we're after is the combination of 15 and 3. How many choices are there for 3 bars out of 15 possible slots where the order isn't relevant to us? So again, the purpose of this example is to illustrate a situation where sometimes the way we choose to represent possible answers or represent the question originally gives us a more difficult road than if we maybe reformatted or thought about the question in a different way. This stars and bars approach can apply to really any question where we are trying to figure out how to partition a certain set among various other subsets. So how many ways can you give? In a similar vein, for the second question, we are again going to reformat or figure out how to write down answers in a clever way that allows us to rephrase it as a combinations question. The setup for the second question is that imagine you live in the middle of a city and you have these city blocks. So say you live at point A and you work at point B, and on your every commute, you actually have a few options for the shortest route. You can go all the way north and then go east, or maybe you go east and then north, or maybe some other combination of these things. What we don't want to include when we say how many shortest routes are there from A to B is we don't want to ever be doubling back. So we want each step to either be going north or east. If we ever find ourselves going south, we're really going in the wrong direction. This is a good example of where it's helpful to write out a few solutions using some sort of notation. And really the point of doing this is to decide for yourself on a notation. And just the act of doing that can often give you hints as to where to go. So let's say, how do I want to write down, how do I want to represent this route? Well, maybe I go, so this route I would describe as going north 3 blocks and then east 4 blocks. So maybe that solution is north, 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 east, 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 east. Another solution might be north, east, 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 north, north, east. So that would be north, east, 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 north, north, east. That would be this route. So after writing a couple of these down, the key observation for this one is that any route from A to B has to go 3 blocks north. right? Because B is 3 blocks north of A. No matter what, you have to be walking north for 3 steps. So every possible solution includes 3 norths and 4 easts. So out of our total of 7 blocks walked, a choice of route going from A to B amounts to a choice of 3 of these that are our north blocks. So I could go in and say maybe it's this one, and this one, and once I've made that decision, then it's implied that our remaining blocks are all east blocks. And then now I have one of the solutions that I'm trying to count. So the question is, how many choices do I have? Well, out of 7 total spaces, I'm picking out 3 of them, and I don't care which order I select the 3 blocks to be the north blocks. So whenever we say something like, order doesn't matter, it's like, well, this question is all about order. It's all about saying, are we going north or east, and in what order? So I really don't like the phrase, order doesn't matter. We want to be a little bit more specific and say something like, the order in which we select which blocks are our north blocks, which of these slots we write an N in, that order doesn't matter. So this solution, north, 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 is the same as this solution, north, north, north. Right? Once it's written down, it's not clear what order it was written down, so it doesn't matter. So in other words, the answer to our question is the combination of 7 and 3. This is the number of ways that we can select 3 spaces out of our collection of 7, which ends up being 7 times 6 times 5 over 3 times 2 times 1, or, well, the 6 cancels with the denominator, and 7 times 5 is 35. So, as you can imagine, there are a bunch of possible questions that really at their hearts are combinations questions. And really the difficulty, or the challenging piece, at least to me, for questions like this, is identifying or deciding on a way of writing things down so that it's conducive to a combinations question. Good first steps is always to start writing down some answers, some of the things that we're trying to count, and seeing if we can figure out what the different options are. If our goal is to write down another one, how many choices do we have when deciding where things go? Often, the question is going to dictate a lot of that for us.